In this lesson, we are going to look at atomic structure, and we're going to look at how those atoms are put together to make molecules and so on. Please understand that this is really background knowledge for biochemistry. Okay, so it's not that this information is going to show up on a test in particular, but it just kind of gives you the background knowledge that you need to understand valence, which is going to help us to understand biochemistry. All right, so let's dig in. Atoms are made of 3 subatomic particles. The first of these is the proton, and I always abbreviate proton P+, because protons are positively charged. The next one is the negatively charged subatomic particle, which I always abbreviate as E- for electron. And then the subatomic particle with no charge is the neutron, and I always abbreviate that N0. Now, this guy right here and this guy right here, these are in the nucleus. Okay, so you're going to find the protons and the neutrons in the nucleus. These electrons, however, are found in the electron cloud. Okay, so you have 2 regions in the atom. You have the nucleus, which is kind of the core or the center of the atom, right? And then surrounding the nucleus is the electron cloud, and the electron cloud exists in layers, and we're going to get into that in just a minute. All right, now bear in mind also that atoms make up elements. So let's talk about what an element is. An element is a pure substance, and we call it pure because it only contains one type of atom. Okay, so one type of atom makes it an element. All right, so the elements are all arranged on the periodic table, and the periodic table that you see here is one that came from an app that I have, just a periodic table app. And all of the atoms are arranged on this periodic table by atomic number, which is on this particular periodic table the number at the top. So let's go ahead and label that the number at the top is the atomic number. The atomic number is the number of protons in the nucleus. Okay, so the atomic number is the number of protons. Okay, so atomic number, number of protons in the nucleus. The bottom number underneath that, when you're looking at a box on the periodic table, is the atomic mass. Some people call this the mass number. This is the number of protons plus the number of neutrons in the nucleus. So notice only 2 subatomic particles contribute to an atom's mass, the protons and the neutrons. Those are 2 numbers we have to have from the periodic table in order to actually draw atoms. Okay, so you need to know those 2 values and what they stand for. All right, so now what we're going to do is we're going to draw some atoms, or we'll at least draw one, and I'll show you how you draw an atom using the information on the periodic table. For our example, I'm just going to take some atoms that I have on your notes. I'm going to take carbon first. Okay, so carbon has an atomic mass of 12, right, and the atomic number of 6. So the atomic number equals 6, and the mass is 12. Okay, so what does that mean? Well, first of all, that means you have 6 protons in the nucleus, right? Because the atomic number is the number of protons. To find the number of neutrons, we know that this mass is protons plus neutrons, right? So you have 12 protons and neutrons, right? And from the atomic number, we know we have 6 protons, right? So all you have to do is take this 12 minus 6, and you end up with 6 neutrons as well. Whoops, excuse me. Here, let me erase that. 6 neutrons, not protons. So 6 neutrons here. Okay. So that's the nucleus of a carbon atom. So there's my nucleus. Now, to do the electron cloud, we're going to have to do something a little bit different. We're going to have to recognize that the electron cloud is split up into shells. So it's kind of like an onion where you have a core and then there's layer upon layer upon layer. And each shell has a capacity, a certain number of electrons that it can hold. The first shell can hold 2 electrons. The second shell can hold 8 electrons, and the third can hold 18 electrons. And you have to know that in order to draw an atom. So here is my first shell. That's the one that's closest to the nucleus of my atom, and it has a capacity of 2 electrons. Now, in an elemental atom like you see on the periodic table, okay, the atoms that you see on the periodic table are the elemental atoms. The number of protons is going to equal the number of electrons. Okay, so if I have 6 protons here, that means I'm going to have 6 electrons. Okay, so I have 6 electrons to place. Here's one, here's another. Now, I am at capacity here. Okay, that shell will only hold 2. I've got 2 in it. So in order to place my remaining 4 electrons, I'm going to have to go to another shell. So I'm going to have to draw a second shell in. Okay, now this shell will hold 8. I only have 4 to place, which is perfect. Okay, I have enough electrons that will fit in this shell, but I don't have to actually go to the third shell. So here's 1, 2, 3, and 4. So I've now drawn my atom based on the information from the periodic table that you see there. All right, let's define just a few terms here as we go on, because some of these are things that I think come up periodically. You'll see the word molecule a lot, especially as we get into biochemistry, because in biochemistry we're dealing with molecules. When we bond atoms together, we call that a molecule. So an example of this might be H2O or CO2, right? Those are molecules. Those are hydrogen atoms here bonded to oxygen, or one carbon atom bonded to 2 oxygen atoms. So those are examples of molecules. You can actually make charged atoms that we call ions by removing or adding electrons to them. So remember I said in the previous slide that the protons and the electrons are equal, and because the protons are positive and the electrons are negative, they balance each other out, right? So when they're in equal numbers, for every positive in the nucleus, there's a negative in the electron cloud. When you gain electrons or lose electrons, then what happens is you throw off that balance, and so your atom is going to have a charge. So examples would be Na plus here, or Cl minus would be examples of ions, and they've gained or lost electrons. In the case of Cl minus, it has gained an electron. So chlorine has gained an electron, and you're saying, well, why is that minus? Well, it's minus because just like in math class, when you add another negative to the atom, right, that's the same thing as putting a negative charge on there, or a minus. Same thing with sodium. Sodium has actually lost an electron. And again, when you add a negative, or sorry, when you subtract a negative, then in math class it's positive, right? Minus a negative is positive. In this case, sodium has lost a negative charge, which means it's now positively charged. The last term that you need to be familiar with is isotope. The key word here in isotope is iso. Iso means same. Isotopes are atoms of the same element with different atomic masses. So what determines what kind of element you have is the atomic number. So hydrogen is always going to have an atomic number of 1, oxygen is always 8, nitrogen is always 7, and so on. And that's how you know what kind of atom you have. But in nature, you can have different atomic masses. You can actually mess with the number of neutrons in the nucleus. So the most common isotope of carbon is the one that's on the periodic table, and that's the one we call carbon-12. And that's 12 because it has 6 protons and 6 neutrons, right? We drew that on the previous slide there. But there's another isotope called carbon-14. Carbon-14 is still carbon, which means it has 6 protons. However, if you take 14 minus 6, you find that you actually have 8 neutrons, right? This 14 refers to the atomic mass. So it's got 8 neutrons instead of 6. That's another common isotope of carbon, carbon-14, and that's what that means. All right, finally, last bit of vocab that you need to be aware of here is the octet rule and valence, okay? And these are going to be important when you're talking about biochemistry. So octet, octo, you know, means 8. So the octet rule says that atoms are stable when they have either a full outer shell or 8 electrons in the outer shell. So carbon, for example, remember carbon, in its outer shell, it looks like this, right? Does carbon have an octet? No, it does not. Okay, carbon does not have an octet. It actually only has 4 electrons in its outer shell. So carbon is actually not a stable molecule or stable atom. If we take this concept of valence, valence is how many electrons an atom needs to have the octet. Okay, so how many electrons would it need to be stable? In the case of carbon, you have 4 electrons in the outer shell, it needs 8, so carbon's valence is 4. What that means is carbon is going to make 4 bonds to be stable. So valence tells you the number of bonds an atom will make. You can do this with nitrogen and oxygen as well. You'll get something very similar. If you do this with hydrogen, what you'll find out is that hydrogen actually has only 1 electron in its outer shell. Now, does that mean that hydrogen is going to make 7 bonds? No. If you draw hydrogen, hydrogen only has 1 shell in its electron cloud, right? So here's hydrogen. It's got 1 proton. It's got no neutrons, and it just has 1 little electron. There's hydrogen, right? So that's what hydrogen looks like. It doesn't have a second shell, so we have to go to the second part of the octet rule, which is full, right? In order to fill hydrogen's 1 shell that it has, you just need 1 more electron, so its valence is 1, okay? So hopefully that gives you just a quick overview of how this stuff works. Like I said, it's valence that we're going toward because this is going to determine how many bonds each of these atoms makes, and then that's going to determine how our biochemicals are put together. So this is kind of just background information for those of you who are curious.